Hi there, welcome to my channel. In this episode, we're going to be looking at how to delete a node from a linked list. I have many other videos about linked lists and data structures and algorithms, especially using Python. For every one of these videos, I have also developed a HTML interactive solution that shows you what exactly is happening in the background. So feel free to jump into the GitHub repo. The link is down the bottom in the description. But for this one, I will go through the basics and I will show you the code. Hopefully it will help a couple of people out there. If you haven't already subscribed, please do. Leave me a comment, connect with me on LinkedIn. I'm so happy to see the people that have actually connected with me and we've had a chat together. So let's jump into this one. Okay, I've got my HackerRank in white and I've got my Jupyter Notebook in black. This will help me teach you how I'm solving this problem. But let me run you through what exactly the problem is asking me to do. The task is delete the node at a given position. So we will be given a position. I'll show you. That's actually here in the code. If I get rid of this annotation, you will see that the user will give you the position, which is here. So the user will say, hey, I want to delete some node at some position. So that will be coming from here, this position, in a linked list. So there will be an existing linked list or potentially an empty one. If it is an empty one, we have been asked to return a null value, but we'll get there. So there is a linked list. We will be given a position and return a reference to the head node. So this is pretty important. The head node is at position 0. Of course, it's a linked list and the head node is always at position 0. The list may be empty after you delete the node. Well, yes, and then you return a null value. Here's a really good example. So if the existing linked list is 0, 1, 2, 3, and the user says, I want to delete the value in position number 2, what we will have to do, we will have to say this is index 0, this is index 1, this is index 2, and this is index 3, which happens to be exactly the same values in there. But if we have been asked to delete position 2, means that we will have to get rid of this value, and the new linked list will look like 0, 1, 3, because we will be deleting the one that's sitting at position 2. So that's the idea. What type of input will we be getting? Let me show you the input first. So in the input, we will be given the size of the linked list. So this is the size. It will have 8 values in them. So that's 1, 2, 3, 4, 5, 6, 7, 8. And this last one is the position that we will be deleting. So that's the position. If I show you the code, here is the list count. Let me draw in red. You will see that the size will come from the list count. Then we will have a singly linked list created, an empty linked list that is created. This for loop will accept these 8 values in this example. It will be coming from this input function, and that will be connected to the empty linked list that we are building here. And then this position will be coming from here. So now you know all the input and what we're going to be doing with this task. Now, let's jump into the rest of this description. I think it's important for us to understand what function we will be completing. Let me scroll up. This is the function that we will be completing. So it's called delete node. And if you look at the code, this is where we will have to add this code that we will be writing. So this function, complete the delete node function in the editor below. Delete node has the following parameters. It will get a singly linked list node pointer list, and it will get a position. So it will get the list and it will get a position. It will do some works, delete it, and then return the head of the singly linked list or just a linked list. Let me start by explaining how this actually works using this example. 20 at position 0, 1, 2, 3, 4, 5, 6, 7. And when the user says that they want to get rid of position number 3, it means that number 19 will have to go away, and the new linked list will look as 26, 2, 4, 7, 4, 15, and 9. So we're getting rid of that number 19. How do we do this in Python? Let me show it to you. All right, before I start, I'll bring in some of the code from HackerRank. I will need them. Once I have dropped that down, chevron, I'll copy this code. I only need this much of it. So bring it in here, put it up here, run it. Okay, and then come down here as well. I will be writing up this function. So this is actually where I need to write the function. Drop it here, run it. I understand it just needs the word pass for it not to give me an error. And then I will probably have to copy these as well. I don't think I'm going to run them, but oh well, let me put them here just in case. Now I'll extend this window. I have all the input from HackerRank. Let me just make sure the indentation here is right because I want all of them to be in the same line. All right, now that I've got all of this, I remember that there is an edge case, and the edge case is that if the list itself, which is the linked list, is none, this is what the task told me. The task told me if the linked list is empty, you just return none. So I will start by handling this. What I will do, I will go up to my definition of the function, and I will say if the linked list is none, then I want you to return none. So let me add one comment here, handling the edge case number 1, which is if the linked list is empty, I will just return empty, and that's my job done. But what if it is not empty? Well, let's continue. The next edge case is what happens if the user tells me that, hey, the position that I want you to delete is number 0. What if the position is number 0? What do we do then? Then we have to, remember, we have to return the list dot next, which is the next head. Let me show you. If I have a linked list, I'm not going to really put anything in there. I'm not really going to put any data in here. I just want to show you that if there is a linked list that looks like this, and this is the end of the linked list, and if the user tells me that, hey, position equals 0, I want you to delete position 0, which is this one here. What happens, I need to go to my list, which is this bit here, the head of it. Because we are getting rid of this, I need to make sure I'm returning the next element. Because if I don't, then I'm not really putting any head to this linked list, which is not going to really work. So in essence, if I want to do that, I'll call it edge case number 2, handling the edge case number 2. And the edge case number 2 is if position equals 0, like the user wants to delete the head of the linked list, you will have to return the list, but what is after position 0, as exactly I showed you in the diagram. We just don't want to break the code. So we have dealt with 2 edge cases, whether the list was empty, so I have very graciously handled that here, and edge case 2 is whether the user wants to get rid of the head of the linked list. Well, I'm going to jump to the next one because I know how to do it. All right, now that we have handled the edge cases, we just go to the general case. Let me just write, I'm just going to call it general case, which is delete a mid or end node. Maybe that's the case. For us to do that, I'll just draw really quickly again. So if I have a linked list that looks like this, I'm not going to put any data in there. And you can imagine that we have got maybe 4 nodes. I know the example has got more than this. But what I want to show you, if the user says, for example, I want to get rid of position number 2 because this is 1, 2, and 3. If they say, hey, I want to get rid of this, we will have to travel and get there. Because in linked lists, you can't just say, hey, give me node number 2. You don't do that. You will say, take the first one, and then go to the next one, and then go to the next one, and then go to the next one, and go. So that's how it works. You can't just say, hey, I want number 2 without looking back or forth. That's not how it works. So if I want to do that, let me draw it again. If I want to get to position, if I want to delete position number 2, I'll have to travel and get there. And I think you appreciate that. We will have to take 0, we will have to take 1, and then that's where we start the deletion. So all I need to get to is position number 1, and then delete the next one, and then connect this to the next one, because this will be gone, right? This is what I will be doing. Go to 0, go to 1, wait here, get rid of this one, and then connect it to the next one. That's what I'm going to be doing. Now, if I do this in the code, I will need a new variable called current, and I'm going to put current to the head of the list. Once I have done that, travel to the position the user has defined. Now, for me to travel, I will need to use a for loop that goes from 0 to position -1. That's exactly what I told you, because if I get to the one before the position, then I can delete the next one. That's what I'm going to be doing here. What I will have to do is, hey, take current and move it to the next one, which this statement here says, hey, go to the head of the linked list, right? And travel to the one the user says just before, which means that if the user says, hey, I want to get rid of position number 2, travels from here, then goes to this one, and it stops here because it knows that the operation of deletion is going to be happening here. How does it work? Because the current here was set to the list. It was sitting at the head. What it does, it says take the current.next, which is this one, and put it into the current. Means that when it is done with this, it will travel next and it will wait here. Now that we are waiting here, the next job is to get rid of position number 2. The way we do that is through this code. For us to delete the position, we will have to say, hey, I want you to put the next of the next into current.next. In essence, what it does, when you have a linked list that looks like this, right, it will say, hey, I want number 2 to disappear. It says current.next, and remember that we were sitting here, right? We were sitting in this one and we were waiting to do some operation. It says current.next, which is this one, and then next, which is this one, connected to current.next. It really nicely gets rid of this one and connects it to number 3. This way you have kind of gotten rid of position number 2, which is really smart. Okay, I think that's it. Now that I have done that, I will have to just return list. And I think it should work. If I copy all of this, right, and if I bring it to HackerRank, let me just open this up. This will be pasted instead of this function, paste it here. Let me just make sure everything is nicely indented. Yeah, it looks like it. I'll move my face to the other side, and then I will run the code. Fingers crossed it will be successful. If not, oh, it is. All I need to do now is to submit the code. Hopefully all of them are successful. Yes, they are. So thank you very much for watching. If you enjoyed this video, hit the like button, subscribe to my channel, and leave me a comment. Let's connect. Let's have a chat. You can reach out to me on LinkedIn in my email. So many different people have reached out to me. We've had a really nice conversation. And don't be shy. Let's have a chat. Thank you, and see you later.